Hello students, today we are going to study the equilibrium of particle and common forces in mechanics. As you know already about the equilibrium. Equilibrium means what? An external force acting on a particle, it is zero. Here in equilibrium we have to consider the both translational as well as rotational motion. So if you will consider the translational motion, for that the net external force is 0, and for rotational equilibrium the net external torque is 0. So the equilibrium of particle, it refers to the situation when the net external force on the particle is 0. So we will discuss according to the Newton's laws. This means that the particle is either at a rest or in uniform motion. So here we will see about the F1 and F2. We have taken the two forces F1 and F2. If we will see, they are in opposite direction. The two forces F1 and F2 act on a particle. The equilibrium, it requires that F1 is equals to minus of F2. You will observe in figure we have taken F1 is equals to minus of F2 because they are in opposite direction. We can write this equation F1 plus F2 is equals to 0. The two forces, they are equal here but they are in opposite direction. Now let us try to understand about F1, F2 and F3. Here we can write the equation F1 plus F2 plus F3 is equals to 0. We can use the parallelogram law of vector addition, and with the help of this we will see F1 plus F2 plus F3 is equals to 0. Consider here F1 we have taken, then F2, they are starting from a common point. We have to see the parallelogram law of vector addition. We have taken F3 as also here. So observe here they are forming parallelogram. So the diagonal of parallelogram, observe it carefully, it is what? Minus F3. So what is the equation we can write with the help of law of parallelogram of vector addition? F1 plus F2 is equals to minus of F3, and that we can write F1 plus F2 plus F3 is equals to 0. So we have got F1 plus F2 is equals to 0, and if you want to write for a three forces F1 plus F2 plus F3 is equals to 0. So here we can use the triangle law of vector addition also. We have taken the F1 and F2, these are the two forces, and according to the triangle law of vector addition, what is we can write? F3, here it is a resultant vector, so we can write F1 plus F2 is equals to F3, but you have to see here the order. By the triangle law of vectors, the three sides of triangle with arrows taken in a same order represent the equilibrium of forces. So equilibrium of particle is nothing but the net external force acting on particle is 0. In that we can consider the rotational as well as translational equilibrium. Now let us try to understand the common forces in mechanics. Here we are discussing the first, it is about the gravitational force. As you know already in chapter number 1 we have discussed the four types of fundamental forces, that is the gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. But in mechanics we will consider only the gravitational force and electric force here. So let us try to understand the some important properties of gravitational force. Here the first, you already know, the gravitational force is universal force. It is pervasive, means here it is acting on every particle, it is present in every of the things. Here it can act at a large distance without requiring any medium because it is contact force. It obeys the inverse square law. As you know the formula of it, with the help of this we can write it obeys the inverse square law. It is always attractive in nature. Next, here it is a long range force because you know the two types of forces, long range and short range. So it is long range force. Here it is a weakest force, as we have discussed the four types of forces, and from these four type of forces this is weakest force. It is a conservative force. So these are the some characteristics of gravitational force. Now try to understand other forces also. Here other forces in mechanics are what? Contact force. So what is a contact force? The contact force is arises due to the contact of one body with another. You can consider solid, fluids. So the contact force, it is because of contact of one body with another. Here contact force, they are mutual forces, as we have learned already about the Newton's third law. For every action there is equal and opposite reaction. Here the contact force are mutual forces for each pair of bodies. Here we will see about the normal reaction and friction. What is the definition of normal reaction? It is represented by the capital R, the component of contact force normal to the surface. The word what we have used here, normal. The component of contact force, it is normal to the surface, it's called normal reaction. And the component of the contact force, it is parallel to the surface, it is called friction. So this is definition of normal reaction and friction. Now let us try to understand about the buoyant force. Here we have taken bucket, in that the water is present. We have taken the solid. The solid, it is immersed in a liquid, and there is an upward buoyant force, and it is equal to the weight of the liquid displaced. Here if you will see the direction of weight and buoyant force, it is what? Opposite. You know about the buoyant force, it is nothing but the upward force exerted by fluid that opposes weight. So buoyant force, that we will discuss in detail about the in particular chapter. So viscous force, air resistance, these are also the examples of contact force. So the viscous force is nothing but the force between body and fluid. Air resistance, it describes what? The force that are in opposition to the relative motion of object as it passes through the air. So viscous force and air resistance, that also we will discuss in particular chapter. Just remember that these are the examples of contact forces. Now let us try to understand the two common force are tension in a string and the force due to spring. So what are these that we will discuss here? You already know about the tension. What is this tension in a string? The restoring force in a string is called tension. So let us try to understand about the spring. Here we have taken this type of figure. We have taken a spring. So what happen if you will apply of external force? See what happen? The spring here is compressed, or it is extended also. Okay, so here what happen? When spring is compressed or extended by an external force, the restoring force is generated, and this restoring force is proportional to compression or elongation, and that we are taking x, and it is nothing but a small displacement. So with the help of this we can write a formula, that is F is equals to minus kx, where F is a spring force and x is what? Displacement, and k is a constant. The minus sign we have given because it is in opposite direction. So here you have to know about this spring force. Here the different contact forces mentioned above arises fundamentally from the electric forces also. As I have told you already, we have discussed the four types of fundamental forces: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Here we have to discuss about the electrical force also, because at the microscopic level we have discussed already about the macro and micro. Micro means what? Very small. All the bodies are made from charged particles, and the various contact force arising due to what? Elasticity of body due to the molecular collision and impacts. So here you have to know the charge constituents of different bodies. For that we have to consider the electrical force also. So these are the some common forces in mechanics. So next time we will discuss in detail about the friction. Thank you.